So good evening. We are happy to have with us tonight Dave, WA3TRS, a longtime member of our Montgomery Amateur Radio Club. Tonight, Dave will share with us his early experiences working with the Navy to install and operate the first NGO satellite terminal on an ocean-going ship, the SS Hope hospital ship. This was a milestone in satellite communication, so we are excited to have Dave tell us all about it. And so thanks, Dave, for coming to join us tonight. And now it is over to you.
Thank you, Alex. It's a pleasure and fun to come to the club and tell everyone about this experience. One correction, though, this particular part of my talk was not with the Navy. It was strictly with Project Hope. The second part, which I'll schedule sometime in the future, was the Navy. But let me start. Okay. Everyone should be able to see the main page. And I call it the Great Moments of Communications because we were doing on a civilian ship a satellite terminal. There had been other satellite terminals done on government, Navy, and other organizations. But this was a what if scenario to test out if we could have satellite communications on a remote medical facility. And why is this not advancing? Oh, okay. So we were featured in various media as we continued with our projects. But this was February 1st in 1993 when we sailed out of Baltimore, and we went down to Maceió, Brazil, with this 8-foot terminal, and installed it on board the hospital ship Hope. I say that this was me in the center, but it turned out to be that's really the president of Project Hope. That was my boss and somebody else. So there are ships today with satellite terminals, no problem. They're using Inmarsat, and there's thousands of terminals now. And they're on big cruisers, so they're on small yachts. Small yachts are using the Inmarsat C, which is a positioning system, very small, very compact. But there was a meeting between the president of Project Hope and Dr. John Walsh, the president of Hope, and they wondered what would be the effect of high quality telecommunications on a remote health facility. So here's Dr. Walsh. He founded Project Hope. And then here was Dr. Cherick, who was the president of COMSAT at the time. Now, remember, we're talking about this in 1972. So Project Hope, not-for-profit, founded in 1958. It's usually identified with the SS Hope. Oddly, unfortunately, they've taken the ship off of its logo, which was sad. But now they're totally land-based, and they turned over the ship from the Navy to Project Hope for $1. And then the Hope was outfitted to look well. It was a hospital ship, but they had put the name on it, so on. And they conducted programs in 80 or more countries around the world. They're currently operating in about 30 or 35 countries. Well, I made my first visit to what the ship was docked in its home port in Baltimore. And this was in December of 1972, and my boss took my picture on the bridge of the ship. But this was an exciting thing for me. I was in the Navy, so this was something exciting for me. This particular picture was in 1963, so and then 10 years prior to that, we were talking to the Hope. And what we did, we provided 3 telephone channels between the ship, Intelsat 4, the COMSAT labs up in Clarksburg, and Project Hope headquarters in Washington on Wisconsin Avenue. So that was 3 telephone channels. We could have voice, teletype, fax, EKG. Interesting fax in those days was a rotating drum with a stylus that went across. Fascinating to watch it, and it stunk. This is a picture of Intelsat 4 that we were using at the time. And then, but in comparison, there's early bird Intelsat 1. So it was quite a bit of a difference between the satellites. And I had to explain to people at my church and here at Asbury when I made these presentations what the orbits mean. So here's low orbit, medium orbit, and equatorial or geostationary orbit. And of course, the geostationary orbit is when the satellite matches up with the rotation of the Earth. Oh, one thing I forgot to say when I was talking, to introduce myself, I worked for COMSAT for 31 years, and unfortunately was laid off in 2003. But as far as working on amateur satellites, I helped build Oscar 6, and I made the 10-meter antenna for Oscar 6. But this diagram is just to illustrate that 3 satellites can give whole world coverage. But because of the traffic, they have one in the west, Atlantic region west, and one in the Atlantic region east. But as time has grown, the satellites have really crowded the skies. So in 2018, you look at that, you can hardly see through. But what's even worse is that in the equatorial orbit, going around, almost every slot in the orbit is taken up. In 1972, we did put that same small 8-foot dish on board the Queen Elizabeth II, and did an experiment going from England back to New York. That was I was not on that voyage, but my boss was. And that's not to say that satellite terminals were not on board ships. Here's whoops, back up. The top picture on the right is the Russian ship. They outfitted their ship for tracking not only their satellites but ours. And then here's a Navy ship that had satellite terminals. But this was on an NGO, a non-government organization ship, and a private industry. So what we did, we departed Baltimore on the 1st of February, 1973. And it's a 2-week voyage going down to, we were in the state of Alagoas in Brazil, the town of Maceió. We had a brief stop in Natal to pick up the president of Project Hope, but we arrived on Valentine's Day, 1973. So that was 4,800 miles and probably an average speed of 14.3 miles per hour or 12.4 knots. Not very fast. When we did depart, there was a lot of hoopla. A lot of people came to the pier to wish us bon voyage. And there was even a fireboat out in the harbor that was spraying water as we decided to as we departed. But at voyage at sea, when we got off of Cape Hatteras, we hit storms, and that made a mess out of one of our trucks that we had on board. But fortunately, our terminal that we had installed survived, and it was welded to the deck, and that survived. When the ship was at sea, it was required to have a radio operator. So this fellow's name was Jack, and he worked in his well, it was the radio shack that we were in, that our equipment was in too. But this is the equipment for use at sea, and he would just sit there all day and monitor for emergency messages. Now today they don't have to. They don't have the radio operators. They've got satellite communications and the Inmarsat C, which gives positions automatically. And what we did for that 2 weeks, my boss gave training of why we were there, what we were doing. The ship they went through and they did. They're doing man overboard drills, which was very interesting. They as soon as they have somebody yell out "men overboard," this case starboard side, that the ship goes into a figure eight and try to go back to the spot where the person went overboard. And they had lessons in Portuguese. This fellow was from Brazil, and I keep on pressing the wrong button. He was from Brazil, so he gave lessons in Portuguese. And here's one of the nuns, one of the sisters, that she was giving lessons in culture. And of course, it's a hospital ship, and this is a passageway outside one of the operating rooms that they had. So they had to make sure that they were clean, they were ready to go for any surgeries that happened when they arrived. I have no idea why she was holding a bottle of fluff. I never did get that explained to me, but she had fluff. When we cross the equator, that's a big deal. And this is Sister Theo, another one of the nuns, and she's mixing up a devil brew for the people who have not gone over the equator yet. And then King Neptune and his court, they held court, and they made people swim in noodles and had foam on the deck, and it was really quite hysterical. When we arrived in Maceió, the president and his wife, the president of Hope and his wife, got off the ship, and then there were meetings and speeches given that the ship was in town and it's going to do all these good things, which it did. Now, as far as the equipment is concerned, the ship had its own amateur radio station, and I don't have the sign up here that shows the call sign. But this fellow on the left, David Veazey, he was Hope's radio operator, and right here he's looking at the rack that we installed with our equipment. This is what we call an FM feedback receiver, 70 megahertz receiver, and then the multiplex equipment for the two of the three channels that we had. We had one channel that went from let's say zero. It's impossible. It was zero up to 20 kilohertz, and then there was a 20 to 24 kilohertz and a 24 to 28 kilohertz channel, in that we modulated onto the 6 gigahertz signal going up the satellite. We went up at 6 and down to 4 in the C-band. Here's a picture of the ham shack on board. It was really quite well equipped, and most everything on here was donated and given to the ship. This particular nurse is calling home. They had a telephone booth where a person could go and be in a quiet, restful location with a telephone. Here's a doctor. I think he was a dentist, and he's calling home on the amateur radio again. They use mostly the Mars frequencies. This was our antenna and our equipment. We had a 300 watt C-band transmitter, 6 gigahertz, some test equipment, and an up and down converter. The low noise amplifier was up here, but I'll show you the transmitter had a problem. But my boss, Kim, this guy's now 99 and still living in Bethesda. He was so happy. He had a bottle of champagne. He said, "Let's celebrate." But we had to have all kinds of personalities from Maceió and from Brazil that came in and wanted to get their picture taken and get in the news. And the one fellow, he made a phone call back to the States, I guess. But interesting to note on this one piece of equipment that my boss has his hand on, that was to compensate for the ship rolling at the pier. It wouldn't compensate for the rolling out at sea, and we didn't have to compensate for the azimuth that the ship was pointing, but we did have a very simple um, method of compensating for the ship at sea. Over here, you can't see it, but there is a pendulum hanging down. It's 1 meter long, and that pendulum would swing as the ship rolled back and forth at the pier. And ships do roll back and forth at the pier. So, and every once in a while, you hear the motor out in there, out of the antenna compensating, and it worked. We had, you just can't really tell right here, is a very large movie camera that the Brazilian news is in there and taking videos. They've got lights all over the place. And then this lady she's at the teletype. She was a secretary. And then here I am at the equipment we had inside. The quality of the first voice channel up to 20 kilohertz was high fidelity. It was really good. We could broadcast music on it. One thing we did use it for was slow scan television. We had an RCA slow scan television, and even the Captain Vesey and the ham shack, he had slow scan television. We couldn't broadcast, couldn't use full scan television, just couldn't have the equipment or the satellite space to do it. But we had slow scan, and it was fair. And here's a lady, she's conducting an interview with two doctors, and that was broadcast or sent back to Washington over the satellite. To break away from the electronics part, here's Sister Theo. She's got a little baby from the hospital. But what is sad is that the lower picture, this nurse is holding a child that had a tumor on its face, and he's holding up his thumb. And in Brazilian Portuguese, he would be saying, "Tudo bem, everything's okay." Well, it wasn't with him. He died. Picture on the right is the lab where all the chemical tests were run for the hospital. Really quite complete. This young lady had rickets, and her right leg has been straightened. Her left leg was done later on, and she was so happy that she's got her leg taken care of. This picture is just a happy hour after the day's work. People gather in a lounge that they had aboard ship, so it wasn't all boring. I took this picture at the bottom of this little old lady. She's collecting trash and boxes on the street. Just on the couple blocks from downtown in this town of Maceió, the people live in cardboard boxes, houses made of cardboard boxes. It's relatively moderate on this side of the town. You go a few blocks away, and it's just abject poverty. The one problem we had with our transmitter, and we think it was the salt air. There's a copper line that goes across the middle, and what we're looking at here, where the arrow is pointing, is a dentist's mirror, a little mirror showing a hole in this copper tube, and that was the high voltage that arced through, and we couldn't operate that transmitter. This happened about 2 or 3 days before our last transmission, and we apparently there was just a wire, a high voltage wire going through this tube, and it arced through to the opposite side from where this mirror is. But you can see the edge of the mirror. It's a circle, and then this is just a reflection of the hole that was eaten through. And if that had happened earlier, it was doubtful if we could have gotten a replacement. That's always had 2 days, and we could operate at a lower power. So that was saying goodbye to the beaches down there. The water was declared unsafe to swim in, and we had to go to a swimming pool. But the water was, though they say the coliform content of the water was just too high and unsafe for us. So here's it's one of the secretaries and her boyfriend. They say goodbye. Now I want to tell you a little bit more about what we did in this. We took a C-119, not this one. I didn't have a picture of the original one, so I got this one off the web, of the C-119 cargo plane, and we went up the Amazon to a place called Tabatinga, and that was way up the Amazon. And we put this terminal. I had these pictures reversed. I shouldn't have done that. This terminal we put at this Army base, and we were all the way up the Amazon and just a couple of miles from Colombia. This shows where we went from Maceo to Salvador and then to Brasilia. We had a terminal in Brasilia, and then all the way up to Manaus, stopped in Manaus to Tabatinga, which is about there on the west side of Brazil. The next project we loaded everything in a C-141 Starlifter at Andrews Air Force Base. Not this one. I got a picture from the web, but here is that one, and there's our satellite terminal and the equipment enclosure, and they're backing it up into the belly of the Starlifter. We went from Andrews Air Force Base all the way to Diego Garcia in the Indian Ocean for the Joint Chiefs of Staff. Go back. And then this is the terminal. While we're on Diego Garcia, we were so much in a rush that we had to have one of the Army and Navy guys at Diego Garcia paint the terminal for us. But here again, we were just doing 1 or 3 voice channels, and we were out there about a week, and our LNA failed, and they had to get another LNA on a fighter jet and fly it from Washington all the way to Diego Garcia in the Indian Ocean. After about a week of that, we got a complaint from Great Britain that we could no longer operate a military installation from Diego Garcia through a civilian satellite, since they owned the property. We had a 99-year lease on the property from England, and we had to pack everything up and go back. So this is the path that we took, going to Diego Garcia, from Washington to Edwards in California, to Hickam in Hawaii, to what's in Anderson and Guam, and then to Clark in the Philippines, and then to Utapao in Thailand, and then to Diego Garcia. We did another project where we went to the island of Spitsbergen and this would be about a year later. This is north of Norway. This picture is in July. We had to wear coats, very cold, but this was a 12 or 14 foot. I think it's a 14-foot dish, and it was quite interesting to go up there. It took quite a while. We flew to England and then to Norway and oh, in Sweden. In Sweden, we installed equipment at the satellite station, Intelsat satellite station in Tanumshede, and then flew on to Bergen, Norway. Then from Bergen, we took this cruise ship, and it took 1 week to go up the west coast of Norway to get to Spitsbergen, or Svalbard, as it's called. And I was chased by a muskox. That was a muskox that inhabits the island of Spitsbergen. There's also an international seed bank now on Spitsbergen, and it's built into one of the mountains. So they've got every kind of seed that the earth has. Now we proved for the Norwegian government that satellite terminal, that 14-foot dish, that would work. We had a 1-degree look angle, and now they have full size antennas with heating and so on. These are, I don't think those are 32 meter. They might be a little smaller, 24-meter size, but they operate into the Intelsat satellites. Then the final project I want to show you is in 1976, and we built a small terminal for NBC, National Broadcasting Company, and we took it to Yellowstone Park for the bicentennial in 1976. And the first fellow here with the brown coat, he did the mechanical design. I did the electronic design, and the fellow with the brown coat, his name was Fred. He was showing the park ranger the equipment, but then in the back you can see Old Faithful spouting up. And for that we got an Emmy. But it took from 1976 to 1993 to get the Emmy for making the first transportable earth station for electronic news gathering. And this was a big, not so big ceremony in New York for receiving the Emmy. That was given to COMSAT. We accepted it on behalf of COMSAT. That's the end of this. I'm gonna save the rest of this for another time. Another project I did for Project Hope, and I went to the South Pacific in 2008 on the hospital ship Mercy. So thank you for listening.
Okay, great. Well, thank you, David. That was very interesting. Kind of amazing. You know, you traveled all over the world.
I've been to 50 countries.
Wow. So it wasn't just Project Hope you're working on, those satellite terminals that were like in Norway and stuff. What was that for?
Well, it's still for COMSAT, but we went there on the request of the Norwegian government to see what kind of satellite connection can be made from that far north, and and working through a geostationary satellite. We only had 1 degree, and it was very interesting. When the sea was calm, we would get multipath We get a signal directly from the satellite, and then it's a signal that's reflected off the ocean, which would almost wipe us out. But when the sea was rough, that reflected beam would be scattered, and we'd have perfect signal.
Okay, well, great. Are there any questions from anybody for Dave? Okay, well, great. Thanks a lot, Dave. It was wonderful to have you and to share your early experiences on something that's really critical, satellite communications,
Right.
the early days.
This is David W.
Yeah.
Terrell. Just a brief comment for David. That was terrific. I used to play with satellites, AO40, and then it broke, and the Leos passed of like 2 minutes. Anyway, QO100 is a geostationary satellite. It came from Qatar, and we are passengers with an amateur transponder. So the reason I bring this up is because you said Brazil. Well, the tip of Brazil sticks out far enough into the Atlantic Ocean so that's in the footprint of QO100. So one of these days I'll get it together and operate QO100. Anyway, for what it's worth.
So what frequencies do you operate on that?
They are, interesting. 10 gigahertz and 5 megahertz. And it's interesting, they have 2 feed horns collinear on the same dish. And it's full duplex, as you can imagine. And it's a digital transponder, or maybe mixing up with another AMSAT project. This is the English AMSAT UK did that. I think just easy to go to England and visit an Earth station, a ham Earth station with QO40, and operate from there instead of lugging all that equipment, Anyway, so.
The company that I retired from, now it's called Legato Systems. It was Skyterra and Mobile Satellite Systems. They've had different names at different times. But they put up a satellite. Its L-band antenna is the largest commercial antenna in space, or at least it was a couple of years ago. It took 2 weeks to unfold it. It's so big. But that feed, I don't know how many feed horns there are, but they can create 1,500 beams on the continental U.S. 1,500 beams, and it's amazing what they do. And that design of the equipment was done right up here in Germantown.
Okay. All right. Are there any other comments before we close for the evening? All right. Thank you again, Dave. It was wonderful discussion. I felt like I did a little traveling tonight. All right. So